Hello, Longhorns. Welcome to Precal, and the first unit we're going to study is linear equations and analyzing graphs. And we're going to start with the rectangular coordinate system. So looking at the coordinate system, we want to first look at the rectangular coordinate system or the Cartesian plane. There are four quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. And if you notice that these start on the positive x-axis with Quadrant 1, and they go around counterclockwise direction, and that's how they're labeled. So Quadrant 1 is in the upper right, Quadrant 2 is in the upper left quadrant, Quadrant 3 is the lower left quadrant, and Quadrant 4 is the lower right quadrant. So you need to remember that it forms a C. All right, so C. C for Cartesian plane. So you probably noticed that the x-axis, this x-axis right here, is like a number line that's in the horizontal direction. And the y-axis is like a number line that is in the vertical direction. And we use these two number lines to identify different points in our rectangular coordinate system. We plot points on this plane in the form of xy coordinates. So if you notice, I put a point here at 6, 5. So this point here is a point that I have plotted on this Cartesian plane using x as 6 as my x value and 5 as my y value. In higher level math class, we begin to talk about the points as directed distances. The x component is the distance or direction from the y-axis, and the y component is the distance or direction from the x-axis. So in this case, the distance from the y-axis is 6 units, and the distance from the x-axis is 5 units. And we're going to talk a little bit more about that here in just a few minutes. In this box on your notes, you should have put the number 4 for 4 quadrants. There are 4 quadrants, starting with the upper right and moving counterclockwise in each quadrant. And it's labeled 1, 2, 3, and 4 in Roman numerals. Okay, so now we're going to look at some general formula review. And we're going to start with the Pythagorean theorem, which you should be quite familiar with by now. A squared plus b squared equals c squared. And you're going to notice that Pythagorean theorem is repeated quite a bit in mathematics and used in different formulas. And we'll look at some of those formulas right now with these notes. So first of all, we're going to review the Pythagorean theorem with this example, example 1. So you can read this while I read it aloud, and then I'm going to expand this page so that we can work the problem together. All right, so example 1, to get from point A to point B, you must avoid walking through a pond. To avoid the pond, you must walk 34 meters south and 41 meters east. To the nearest meter, how many meters would be saved if it were possible to walk through the pond, or maybe even possibly swim across the pond? So that's what we're trying to find out, is what would that distance be? So let's take a look at the Pythagorean theorem and see if that can help us. All right, so here I've drawn a picture of our problem situation, and I'm beginning here at this point, and I want to go 34 meters south and 41 meters east to get to the other side of the pond. And I want to know, well, if I could swim across the pond or walk through the pond or walk across the pond, how much would I save? So really what I'm trying to find out is how far is it from X, the black X, to the red X without having to go around the pond. So this is what I'm trying to find. I'm trying to find C. And I know that side A is 34, and I know that side B is 41, so I can find C by using the Pythagorean theorem. All right, so the first part of the Pythagorean theorem is 34 squared plus 41 squared equals C squared. This would be A squared plus B squared equals C squared. So let's determine what that will be. All right, so when we add 34 squared plus 41 squared, we get 2,837. But now what we need to do is take the square root. We have to take the square root of both sides in order to find C, because that's what we're looking for. We're looking for C. And we find that C equals approximately 53.3. Approximately 53.3. All right, well, we know that's how long it is between the two X's if we go straight across the pond. But that's not what we did. We walked around the pond. So the question is asking, how many meters do we save? So what we need to do is we need to take the difference between what we walked around and when we went across directly. So we need to take that difference. So we have to add our 34 meters going south with our 41 meters going east, and then we subtract our 53.3, which is the meters that we would have if we went straight across. We take the difference between those and we come up with 21.7 meters. So if we could go straight across without going around, we would actually save about 22 meters. All right, in the next example, example 2, it says an isosceles triangle has congruent sides of 20 centimeters. The base is 10 centimeters. Find the height of the triangle. And since we're working with Pythagorean theorem, we're going to use the Pythagorean theorem. All right, so here I've drawn an isosceles triangle with sides of 20 and a base of 10. So what we're looking for in this isosceles triangle is we're looking for this height right here, this dashed line that I've drawn. So it's not 20 and it's not 10, so we need to determine what the length is of this line right here. This line right here, this height of this triangle, cuts the isosceles triangle in half. That means that each side right here is going to be half of 10. So each one of these sides is going to be 5. So in order to find this length right here, this height right here of this part of the triangle, which would be the center line, we're going to use the Pythagorean theorem again. Now, if we use the Pythagorean theorem, we have to remember that this side right here would be like side B. Because this right here, if we're going to use this triangle, then this is going to be side A, this is going to be side B, and this diagonal part is our hypotenuse. So you have to keep that in mind when you're doing the Pythagorean theorem. You need to always know, where is my hypotenuse? Your hypotenuse is always across from your 90-degree angle. So here's my 90-degree angle that's formed by this height of my isosceles triangle. So the side that's opposite from this 90-degree angle is this right here. This is my hypotenuse. So I've labeled the triangle that I'm going to use with the Pythagorean theorem. This side right here is, I'm going to call that side A. I'm going to call this side B, which is also the height. It could be called H as well if you wanted to do that, but don't confuse that with hypotenuse. That's the height. The C, this one right here, the diagonal one, that is going to be my hypotenuse. So that's going to be side C. So if I'm using the Pythagorean theorem, this is what that is going to look like. All right, so this is 5 squared, which is our A squared plus B squared, I don't know what B is yet, we're going to find out what it is equal to the hypotenuse squared, which is 20 squared. So I've substituted in the values that I know for my triangle into my Pythagorean formula. All right, so in order to solve for B, I'm going to have to subtract this 5 squared from both sides of my equation. Here's my equal sign. So I'm going to subtract 5 squared from both sides, and I'm going to rewrite my Pythagorean formula so that it's c squared minus a squared equals b squared. And then I'm going to solve for b by taking the square root. So when I complete my equation, I have 20 squared minus 5 squared. Taking the square root gives me 19.4. So B is equal to approximately 19.4 centimeters. The next thing we're going to do is prove that the distance formula is like the Pythagorean theorem. I'm going to start with drawing a diagram, and then I'm going to explain how we can prove this. All right, so first of all, to prove this, I've drawn the first quadrant of a Cartesian plane. I've put in a couple of x1, y1, an x2, y2, and this point down here that would form the right angle is actually x1, y2. Okay, because this is the same x1 and this is the same y2 all the way across. So we're going to use the distance, we're going to use this diagram to prove the distance formula. All right, so first of all, the difference between my y values, this y2 minus this y1, this absolute value, or this distance right here, would be like side A. And this distance right here between my x values, between this x1 and this x2, is going to be this value right here, which would be like side B. So if I wanted to know what the distance was between these 2 points right here, if I wanted to know that distance, then really what I'm using is the Pythagorean theorem, because these two distances right here form a right triangle, and this line right here, the red one, is my hypotenuse, and this is also D, or my distance between my 2 points. So basically all we're doing when we're using the distance formula is we're using the Pythagorean theorem. It's the same thing. So here I've written the distance formula. D equals the difference between the x's squared plus the difference between the y's squared, and take the square root. That is the same thing as the Pythagorean theorem. Here is C, is the length of my hypotenuse, is equal to side A squared plus side B squared, take the square root. So basically all we're saying is that x2 minus x1 is the same thing as A. So if I were to just call this length right here, I could just call that length A. I could call this length B. That would be my y squared minus, or my y2 minus y1 squared. And I could call that B. That would be my B squared in my Pythagorean theorem. and that's it. So you see how the distance formula was actually derived from the Pythagorean theorem. All right, the next formula we're going to look at is the midpoint formula. I know you've been using these for a long time, but let's review. All right, say we have a point between, or we have a midpoint between 6.43 and negative 10.74. And we want to find out what the coordinate is for that midpoint. Well, we can use our midpoint formula. Okay, notice first of all that I labeled my points. I labeled them, this point as x1, y1, and I labeled this point as x2, y2. And that's really important to do because when you start substituting numbers into formulas, sometimes we get confused about what goes where. So if you label your points first, then it's easier to plug them into whatever formula it is you're using. You should do that every time you're having to substitute. Also, a good thing to remember whenever you're substituting in a negative number, like right here I substituted this negative 10.7 into my formula. Any negative numbers, you always want to make sure that you put those negative numbers in parentheses, especially if you're using a calculator. Anytime you substitute a negative number into a formula, it must be in parentheses. Please get into the habit of doing that because where mistakes are made is right there. When you plug in a number into a formula and you don't use parentheses around your negative number, that's when problems happen. Okay, so just make sure that you are using your parentheses around your negative number. All right, so when we calculate this, we get the point negative 2.15, comma 3.15. So my x midpoint is negative 2.15, and my y value for my midpoint is 3.5. So just make sure that you remember that when you're using the midpoint formula, you're looking for a point that's in the middle of your line. That means that it's a point. It's not a length, it's not a distance, it's not any of that. It's an actual point, an XY coordinate. All right, so in the next example of your notes, it's asking you to find the value of P so that negative 2, comma 2.5 is the midpoint between P2, which is x1, y1, and negative 1, 3, which is x2, y2. So in this case, we're trying to find x1. Well, how do we do that? Well, we're still going to use our midpoint formula, or at least a part of our midpoint formula. All right, so we know that negative 2, comma 2.5 is the middle point. But we don't know x1. We do know x2. So all we're going to use this time is we're going to use just the first part of our midpoint formula. We're going to try to find x1. All right, so I've only used the first part of the midpoint formula because I'm only missing the x1 value. I don't know what the x1 value is. This P right here is representing my x1. I don't know what that is. So that's what I'm trying to find. So what I'm going to do is I'm going to use my midpoint formula here. And I'm using x1 plus x2, which x2 in this case is negative 1. So x1 plus negative 1, see how I put that in parentheses? You see that? Divided by 2, that's all part of the formula, equals negative 2, because that is my x value for my midpoint. It's negative 2. So this is the only part of the formula I'm going to need to find my value for P. So my next step in solving for p, or x1, is to multiply both sides by 2. And that's how I'm going to get rid of this 2 in this denominator. If I multiply both sides by 2, that will allow me to cancel out the 2. And since I multiplied this side by 2, I also have to multiply this side by 2. So once I do that, I end up with x1 minus 1 equals a negative 4. Now all I have to do to solve for x1 is to add 1 to both sides, and that's going to leave me with x1 equals negative 3. So my final answer in this problem is that p equals negative 3, because when I solved for x1, I got that x1 equals negative 3. All right, so the next thing we're going to look at is circles and the formula for a circle. And the point xy lies on the circle of radius r and center hk if and only if the quantity x minus h squared plus the quantity y minus k squared equals r squared. Now, if you look at that formula for a circle, you're going to say, that sure looks familiar. Didn't we just do something that looked a lot like that? And the answer is yes, we did. It was the Pythagorean theorem. So guess what? The formula for a circle is the Pythagorean theorem. So in our first example, we're going to write an equation with a center of negative 1, 2, and the point 3, 4 is on the circle. So let's draw a picture and see what that looks like. And guess what we're going to use? Pythagorean theorem, and we're going to find the answer. All right, so for the first step, we're just going to plug h and k into our formula for a circle. So remember, when you plug in a negative number, you have to put it in parentheses. So here we have x minus parentheses negative 1, the quantity squared, plus y minus 2, the quantity squared, equals r squared. So we're almost done here, except we don't know what the radius is. So we have to figure that out. So we're going to do that by drawing a diagram, drawing the circle, and then finding the radius using the Pythagorean theorem. All right, so I've sort of drawn a diagram here of what we have. We have a center right here of our circle, and I know my circle's not perfect, but I think you can get the idea. This right here is our center. That is point negative 1, 2. And the other point is a point on the circumference of the circle, which is 0.34. So I've drawn that point in as well. And what we're trying to find is this right here. This would be the radius of the circle. So what I need to do is I need to draw in a line that goes straight down. I'm going to use the color blue. It's going to come straight down from my point down to my y value right here, which is 2, and a line that goes straight across from my center to that blue line. That's going to represent my x value. And see how that creates this right triangle? And now that I have a right triangle and I know the sides of my right triangle, how do I know the sides of my right triangle? I can count these, the difference between my y values right here. The difference between my y values is 2. And the difference between my x values is 4. And since I know those two distances, I can now use the Pythagorean theorem or the distance formula to find my radius. All right, and I find that the radius is square root of 20. And I'm going to leave that like that because when I write the equation for the circle, I have to square that anyway. So the square of square root is just going to be 20. So square root of 20 squared is just 20. All right, so now I'm ready to rewrite my equation, and I'm going to have x plus 1, because x minus a negative is the same thing as plus, squared, plus y minus 2 squared equals 20. And that is going to be the equation of my circle. Okay, in this last example, we have to write an equation of a line that is tangent to the circle found in the above example at the point 3, 4. All right, so let's go ahead and draw this picture one more time, or actually we can just use the picture above. That's what we'll do. And then we're just trying to find the line that's, the equation of the line that's tangent to this circle. So let's go ahead and use the circle above. I'm going to go ahead and copy it over so that you can see it again. Okay, so for this problem, we're actually looking for the equation y equals mx plus b for this line that is tangent to this point on our circle. So we know that tangent lines are perpendicular to the radius. So this radius line right here we know we just found, and the endpoint right here is 3, 4. So what we need to do is find the slope of that line, which is pretty easy to find because we already know that the rise here is 2 and the run is 4. So rise over run would be 2 over 4. So we know that the slope for the radius line, the slope for our radius line right here, we know that slope is 1/2. Okay, so 2 over 4 is the same thing as 1/2. So rise is 2 right here. This would be our rise. This would be our run. So 2 over 4, that's going to give us the slope of this line right here. So we know that this line, the tangent line, is perpendicular to that one. So we know something about the slope of perpendicular lines. We know that the slope of perpendicular lines are opposite reciprocal. So what is opposite reciprocal of 1/2? Well, that would be negative, opposite sign. So negative 2 over 1, reciprocal. So the slope for the perpendicular line, and I'm just going to write perpendicular here, is negative 2. So that helps us try to find the equation of this line. So one more thing we need. Well, if we know the slope is negative 2, and we know that the point 3, 4 is on the line, then we can use the point slope formula to find the equation of this line. The point slope formula is y minus y1 equals m, which is slope, times x minus x1. Now all we're going to do here is substitute in our point 3, 4 for y1 and x1. So we know that 3 is our x1, and we know that 4 is our y1. I'm going to go ahead and label those, and now I'm just going to plug those in to my point slope formula. Alright, so I've plugged in the 4 for y1 and the 3 for x1, and I simply simplified this, and I know my slope is negative 2, so I plugged in negative 2 for slope, and that gave me y minus 4 equals negative 2x, because negative 2 times x is negative 2x, and negative 2 times a negative 3 is a positive 6. So that gives me a negative 2x plus 6. The next step is to get y by itself, so I'm going to add 4 to both sides. So we add 4 to both sides, and we get y equals negative 2x plus 10, and this is the equation of our tangent line, and that's all there is.